The first thing we need to do in order to find the scale factors to make big or small is to identify corresponding sides. So when we look at this picture, I'm noticing that the 36 on this parallelogram is the longer of the two sides. So 36 is the long side. It's going to correspond to 24 over here because 24 is the longer side there. So now we have to look for the scale factor. We need to think, how many groups of 24 can I make with 36? So I know that I can fit one full group of 24 in, and the remaining part is only 12. So I can fit one full 24 in, and the next group of 24 is only 12 out of the 24. And then we need to recognize that that is equal to 1.5 by simplifying. Now to make small, we kind of look at it the other way around. Instead of saying how many 24s can I make to get to 36, we need to think how many of the 36 I need. So if I'm going to start with 36 and I only want 24, I only want to keep 24 of the 36. So 24 of the 36. Now when we simplify that, we can simplify that by dividing both by 12, and we would get 2/3. You'll remember that in class we talked about how the two scale factors are reciprocals of each other. If we look back at the 1.5, we can look at changing that to an improper fraction, and that is equal to 3/2. Notice that these two are reciprocals of each other. So once you know one scale factor, you almost automatically know the other scale factor. Now we're going to look at using the scale factors to find the missing value of x. So I'm noticing that x is on the larger of the parallelograms. And so I need the 16 to scale up to x. The 16 has to get bigger to correspond. So that means I'm going to use a scale factor that makes it big. So I need to do 16 times 1.5. To make this problem easier, I'm going to do 16 times 1 and 16 times 1/2. Half of 16. Half of 16 is 8. I bring those two pieces together and add them up, and I get 24. So x is equal to 24. All right, let's look at this one. Again, we have to identify corresponding sides. So the short side of this rectangle is going to correspond to the short side of this rectangle. To find the scale factor that makes it big, I'm going to think, how many 12s will it take to make a 15? So I know I can fit one full 12 in there. And the next group of 12, I can't fit another full 12. I can only fit 3 of the 12. So that means I can fit one full 12, and the next group is only 3 out of a 12. We would want to simplify this, and we would notice that it's equivalent to 1 1/4. Looking at the scale factor that makes it small, we're going to say I don't want to keep all 15. I don't want to keep all 15. I only want 12 of the 15. So I only want 12 of the 15. If we simplify this, you're going to notice that we get 4/5. Thinking back, we know that these two scale factors should be reciprocals of each other. And 1 1/4 is equivalent to 5/4. So they are reciprocals of each other. To find the missing side, we're going to use our scale factor. So let's think about what scale factor I need to use. I need to get the 16 enlarged. So I need to use a scale factor that will make it big. So I'm going to times it by 1 1/4. So 16 times 1 1/4. 16 times 1 and 1/4 of 16, which is 4. We bring the two together and we get a total of 20. So x is equal to 20. To find the scale factor to make it big, we need to identify the corresponding sides. So 8 and 20. And we just have to think how many times 8 goes into 20. So I can count 1 8 and another 8, and that gets me to 16. And so I need another 4. So I need 2 full 8s. And the last one is 4 out of 8, which would be equivalent to 2 and a half. Now, as an improper fraction, that's equivalent to 5 halves. So the scale factor to make it small would be 2/5. Now, to find the missing side lengths, we have to use the correct scale factor, and we have to think about, do I want to use a scale factor that's going to make it large or small? So looking at the picture, I need to find x, and that corresponds to 20. So I'm thinking, does 20 going to get bigger or smaller? And I'm going to notice that it's going to get bigger. So I want to use a scale factor that makes it large. So 20 times 2 and a half. So 20 times 2 and a half would be 20 times 2 and 20 times a half. Half of 20 is 10. Together, that makes 50. So x is worth 50. Hit pause and try this one on your own, finding the scale factors and the missing value of x. Alright, so for this one, our corresponding sides are 6 and 18. So how many groups of 6 can I make? I can make 3 groups of 6. It goes in evenly. The scale factor that would make it small, we would think, of the 18, how many do I need to maintain and keep? Well, I want to keep 6 out of the 18. And that's equal to 1/3. Those are reciprocals of each other. So it's pretty easy to find the missing side. We want this 36 to get smaller this time. So we want to use the scale factor that makes it small, not the scale factor that makes it big. So I want to do 36 times 1/3. So 1/3 of 36. So we want to think about breaking 36 into 3 even pieces. That would be 12, 12, and 12. So 1/3 of 36 is worth 12. Okay. So x is worth 12. We're going to look at solving that previous problem a different way. In class, we talked about how there's a scale factor and there's also a relationship within shapes. So I'm going to look at the 18 and the 36, and I'm going to think about how they relate to each other. I know that 18 times 2 would get me to 36. So the small side of the rectangle, if I multiply it by 2, it will give me the longer side. I'm going to use that relationship with our other similar figure. I take the short side and I multiply it by 2, and it's going to create the long side. So 6 times 2 is 12. Okay. All right, hit pause and try this one on your own. All right, as we solve it, we're looking for corresponding sides. So we're saying that 12, how many 12s does it make to make a 30? So I've got 12, 24, so another group of 12. And that gets me to 24, and then I need 6 more. So I need 2 full 12s, and the last one is only 6 out of the 12, and that is equal to 2 and a half. 2 and a half is equal to 5 halves, so the scale factor to make it small would be 2/5. All right, so let's take a look at finding the missing side. So I'm noticing that I need to get x, which means I need that 4 to enlarge. So I'm going to use a scale factor that makes it big by 2 and a half. So 4 times 2 and a half. 4 times 2 is 8. And half of 4 is 2. Together that makes 10. So x is worth 10. And the last problem we're going to look at is the one that was on the previous slide, but we're going to look at the relationship now and how to use that relationship. So I want to compare the side that's 4 to the side that's 12. I know 4 times 3 is 12. Now conversely, I know that 12 divided by 3 is 4. So looking at this 30, I know I don't want to times it by 3 because that would create a really big number, and I know that x is smaller than 30. So I know that I need to use that division rule. I need to say 30 divided by 3 will give me my missing side.